I would like to invite Kris Nair, founder Kawa Space, and Sanjay Nekkanti, founder of Dhruva Space. Hi, Kris. Hi, Sanjay.
Hi.
Hi, Srikanth.
Hey, glad to have you on panel here today. So let's get started. We have a lot of ground to cover, and we are very eager to hear your thoughts on some of the key questions. So before we start, for us all, just walk us through a little introduction of yourself and how you came about starting your respective companies and what actually drove you to do that. We want to hear about your journey. So Kris, tell me what got you into SpaceTech and how did Kawa Space come about?
Right. Hey, thanks. Me starting one SpaceTech was somewhat accidental. Just as a term of background, I studied physics and then worked with early stage companies in India since 2004. And in 2015, we had a chance to kind of create a group and create a satellite. That is where Sanjay and I first met and worked together. So Sanjay has been at it for a much longer time, but that was probably the first time kind of the larger momentum kind of built up. It was a very small group of about four and a half people. Why I say half is one person was part-time. She was instrumental, so this particular group comprised of Sanjay and a couple of our friends. The larger idea was to kind of build something, launch something. It was not a company, it was more of a program to kind of test our skills and fundamentally to kind of prove it ourselves that hey, can we do a complex program management and can we build something amazing, which we haven't thought of, and go through the entire process, right? The expert there were a couple of people, including Sanjay, and Sanjay has much more experience than me. So it was accidental for me. I think it was for Sanjay, it was his calling. And that's how we kind of started. We eventually launched it, kind of became India's first private space mission of sorts. And then I took a thesis, which is after that particular launch, took a thesis of software has eaten the world. If that is the case, is space next? And pursued that thing through Kawa Space. So that is how we kind of, and now we are here.
Awesome. So your space journey is a sweet accident, if I were to
Absolutely
put it that way.
Absolutely.
Interesting. Sanjay, how did you get into SpaceTech? So looks like you and Kris already met before. So I want to hear, I'm curious about your story now. How did you start and how did Dhruva Space come along?
Sure. So I think on November 26th, we would be more like 10-year-old space company, also happened to be India's first private space company. So my journey actually started way back in college, I would say. I started building satellites when I was 19 years old. I was part of a student satellite program in Chennai at SRM University. And, when we were building this first spacecraft, ISRO had given us a challenge that, within 2 years of, submission of our documents and our proposal, we should realize the full spacecraft. And, we were given a shoestring budget. So our initial process was to, just buy components from all over the world and put it all together. And then we realized that, if we were to do that, the costs were too high. And, we had to actually build the whole spacecraft ourselves. And in this process, I realized that, we are a country with 1 billion people, right? But there's not a single private company in India today that is, building satellites or launching them or operating satellites and offering services using satellites. And so why is it that in a country with 1 billion people, nobody would do that, right? Either it's extremely hard or, people, or there's some other issue why somebody is not doing it. For me, it was more like, to be very honest, I felt very maybe it was, you call it patriotism or whatever, but, I felt very shameful that, why somebody is not doing it. And that was the real motivation for me to start this company, Dhruva Space, essentially to lead the privatization of satellite industry in India. And today, so I think I'll give some context over here, right? So from the 1950s until 2020, there were probably about 15,000 satellites launched. It is estimated that in the next 10 to 15 years, there will be anywhere between 60,000 to 100,000 satellites being launched. I mean, that's a staggering number, right?
Yeah.
So who is going to produce these, right? Now you put India in spotlight, right? The Indian space program is well known around the world. India has launched more than 350 foreign satellites on the Polar Satellite Launch Vehicle. Oftentimes, our frugal innovation is given a lot of importance by foreign space communities, so on and so forth. So we are now building a company that is suited for the upcoming requirements. So we operate on the space segment where we build satellites, on the launch segment where we build interfaces between the spacecraft and the launch vehicle, essentially enabling our satellites to go onto any rocket in the world. And once you build and launch the satellites, we also do the third element, which is operating satellites once they are in orbit.
Interesting. So we have a student whiz kid and an accidental entrepreneur on stage here. So this is quite amazing. So so I want to switch gears here, right, and actually go back. So when we say space tech, so obviously it consists of satellites moving in the orbit, okay, and that's pretty much the visualization most of us have. But obviously there's got to be more than that. And I'm pretty sure there is a structure to what is called as a space tech sector or industry. So for the audience out here, Kris, can you structure what, when we say space tech, is it just throwing satellites and is just like a one blob, or is it made up of multiple segments, which each of which are areas of innovation? So can you give us the lay of the land of what space tech means?
Right. Space tech, you can broadly define, for extreme generalization, you can say like the upstream and the downstream, and there's a little bit of midstream as well. In the upstream, when we think about generally space, because ISRO has a very, very stable, very public platform to launch the PSLV, the rocket comes into play. The rockets are primarily built to kind of send things to a certain orbit, whether it's a low Earth orbit of around 500 kilometers or much, much above. The things which go inside the the spacecraft is another mega industry, right? Of course, rockets are one part of the entire larger space puzzle. And these spacecrafts most times is fitted with one sensor, right? Which is basically a flying sensor. These are input mechanisms, whether it's a camera or any other radio antenna, which is sensing or broadcasting. And then all the data, which is generally, like Sanjay said, there will be about 100,000, hundreds of thousands spacecrafts in the years to come. All of these satellites, even at an individual level, these sensors capture terabytes of data. That has to be brought down to human consumption, right? So then you have to kind of downlink that specific data to the ground, where there's the mega potential in creating ground segment, which Dhruva and a bunch of other people are doing. Let's say call it the ground stations. These are all raw data coming from whether it's like a high resolution imagery or radar data or multiple other data sets. These are like, each file would be like, let's say about 400 megabytes to going up to like 6 GB per scene, right? And you have to process it, stabilize it, then handed over to the end customer. Everything space is fundamentally doing, at least at a majority scale, is for the betterment of Earth, because we are observing the Earth, primarily through images or anything. Then you have the downstream industry, which is kind of making sense of this particular sensor data. Imagine hundreds of thousands of sensors flying around in certain orbit and sending you data. That's a lot of data to manage, right? Petabytes of data on a daily basis. That's where the biggest problem for 7 billion people, everything we do, like n number of satellites going up, like I mentioned, it is for the betterment of Earth, of the common man. Now, how do you kind of make that particular data accessible and usable and pretty much easy to use for the end customer, who's primarily one of the 7 billion people out there? So that's where the organization part comes in. That's where Kawa Space plays in. When all the satellites downlink to a ground station, it comes to a platform like ours. What Kawa Space is fundamentally, Kawa Space is organizing world satellite data and making it universally accessible, queryable, and instantly useful. We work with global agriculture, infrastructure, finance, companies and their teams to provide a simple to integrate APIs for satellite imagery and the geointelligence derived from it. It could be then can be used into end user requirement. We like to understand how well the crops are growing in Uttar Pradesh, or very larger macro situations like what all crops in a season a state is growing, right? Let's say that the corn is pretty much like in a peak at this point in Telangana. The government knows, even at the central levels, that, hey, what's going to be the minimum guarantee prices in it. So these are really tickling down to the policy level decisions, which is actually the input is the satellite-based sensor, and the processing happens after that. Or to a absolutely radical way of assisting a very large cement company and giving them alert every time somebody starts making a basement. So that it could be a very good lead for them, because if somebody is building a house, it could be an interesting option for them. Right now, most of these things are done through human beings floating around in every villages and looking at it. Of course, from a market perspective of this particular data, the whole industry is supporting to kind of gather data. Everything related to space is key to nation states, whether it's from a policy perspective or national security perspective. So companies like us, both upstream and midstream and downstream, work with security teams of some of the nation states to kind of cater to their geointelligence needs, whether it's border monitoring, maritime observation, etc. So to wrap, you can broadly upstream, midstream, and downstream. Each place has dozens of components in it, and each one has tremendous TAM to kind of build and serve.
Interesting. I have a few questions on that, but I'll want to hear, Sanjay, how you see from your vantage point how space tech as a sector is structured.
Yeah, so I think Kris gave a very, very good narrative of the upstream, midstream, and the downstream. I'll probably add more elements to it just to give more context to the audience. So I would say on the upstream part, you have upstream and the midstream part, you have your space segment, which deals with manufacturing of satellites. Then you have launch segment, which deals with putting the satellites in orbit. The next one is the ground segment, which deals with operating satellites or getting data out from satellites, typically operations of satellites. And then on the final element, on the downstream, you have everything with respect to analyzing the data coming from these space assets and deriving decision intelligence for various industries. Does that give you a good perspective, Sri? Okay, I think
Sri dropped. So let's continue then, while Sri comes back. So let's talk about one of the points we both were kind of commenting on at a stream level. Just to fill in, this is a follow-up question on what you said. Integrating and creating a spacecraft which can actually do advanced activities of monitoring a place, right? A sensor which is flying around in a certain speed. New space is all about like, cost-effective, low Earth orbit assets, which can actually bring true value to the end user, whoever that end user may. Historically, like we know that these are all heavy, as big as a room kind of satellites. But now you guys are doing something, all the things which can be achieved by a room-sized satellite, and pushing it down to your platform, which I'm aware of, it's called P30. What has changed in the way we kind of see? 10 years back, everything was controlled by mega corporations and certain like space agencies. And then companies like us turned up and said that like, that's too big, it's too expensive. 700 million for an imaging satellite doesn't make any sense. You guys do it at like a fraction of the cost. Like, I mean, like, it's ridiculously cheap, right? How do you do it?
Yeah. So, Chris, so traditionally, satellites have been very, very big, right? Like, we would imagine that the size of a particular room. It used to cost, as you mentioned, hundreds of millions of dollars and take like 5 to 7 years to build. But the biggest challenges with some of these missions is also, one is single point failure. Second is, the revisit times. So for example, how fast can you revisit a particular point on Earth? And also in terms of, getting in newer technology into space pretty fast, right? These are questions that the large satellites don't really answer. So then, in early 2000s, there was a professor in the US who came up with this concept called CubeSats, which are extremely tiny. And, for a fraction of cost of a large satellite, you can produce and deploy several of these satellites that would give you, data continuously. So instead of getting data every 21 days, if it's an imaging satellite, you can get data every few hours, right? But the resolution or the quality of data may not be as good as a very large satellite. But, if you're getting a good revisit time, then you could build several applications around it. Now, I think where really the tipping point happened is, when Planet launched their Earth observation constellation. Today, they operate the largest imaging constellation in the world. All the other industries who started buying data now started looking at having their own assets, right? And now, when you go deeper into understanding the unit economics or the businesses, traditionally, satellite manufacturing companies used to build one satellite every few years for a couple of millions of dollars, and they're done, right? Now, the satellite manufacturer will not take the responsibility for launching the satellite. It is the responsibility of the business to also find a launch. It's also the responsibility of the business to set up their own Earth station to operate these satellites. And, typically these satellites all are in the low Earth orbit where, the satellite is going around the Earth 14 times a day. That means it's collecting tremendous amount of data, as you mentioned. And if you don't bring down this data, then you're not making the best usage of your asset, right?
Right. And just as a, sorry, please go ahead.
Yeah. So where I'm getting at with this is, your costs, your reliability, and faster turnaround time play an extremely important role in today's space tech industry. And those are some of the pieces that we've been trying to address using our platforms, where businesses need not, work with some 15, 20 vendors, but can just come to somebody like us who would take the responsibility of having the asset and giving them the data. So they can focus on deriving decision intelligence out of this data.
Perfect. And the shift, which is basically the tailwind around it, also is interesting because the mega satellites were required to kind of get a certain resolution at that particular point, because the decision intelligence was primarily about you get an imagery, then there are about 300 people sitting in a room looking at that high resolution imagery and highlighting certain things. In the last 7 years, what happened is the resolution per se doesn't matter too much anymore, because human beings are not per se doing it. Like right now, I can create using our platform, I can create the entire farm boundary of the entire Southeast Asia in 6 seconds. They're not human beings sitting and drawing it. The developments in machine learning can actually, so earlier you needed a mega satellite to kind of click an imagery of 1 meter resolution of the Earth. Now that can be done with a 10 kilogram satellite or much lesser, because it's not human beings sitting there and making sense out of it. It is an algorithm which is fundamentally doing it. Hey, Sri, you're back.
Yeah, yes.
Kind of doubling down on how the market shifted from a broader, very large satellites to younger companies miniaturizing it, yet serving the market in I would say 100x efficiently. Thanks to the broader developments happened in machine learning and other associated areas.
Yeah,
Please.
in fact, the earlier question I wanted to ask was, we talked about turnaround time, and what I could glean from your earlier statement, opening statement, was that there is the data that's coming back from whether it's in the form of images or any other format is basically an integral part of the decision support systems for pretty much population scale initiatives, right? Like you talk about agriculture as a use case. So now, obviously, there is data coming in, and you talked about, give examples of file sizes, for example, right? Now, when you're talking about such large data with such large file sizes, how real time can this data really get is the next question, because the higher the resolution, the larger the data set, and the longer it takes to reach, and the longer it takes to process. So are you seeing any drastic improvement on, first of all, give us an idea of what typically the latency is, and are there any factors that are going to decrease the latency to make it real time, or at least quasi real time?
Right. So it will be near real time. Right now, what we get is that, let's say we sync imagery from every commercial constellation ever, right? Like in whatever is operating, we sync data from it. The challenge is like you mentioned, the satellites are getting better and better at imagery, right? A synthetic aperture radar of an entire sweep of northern India would be let's say X GBs. Bringing it down, there is a little bit of pipe issue. Let's say they will use certain kind of downlinking mechanism, whether it's an X-band based or in the years to come, more of an optical way of say laser connected downlink. Once it comes to it, earlier, it used to take about 72 hours or so to kind of stabilize that particular imagery. Stabilizing, I'm not using the technical word, I'm just using it for the broader sense, and then run programs on it or even look at it, right? That has kind of drastically shifted down to a few minutes, right? Which kind of happened in the last 2.5 years, where more and more platforms are emerging. Right? The data in the years to come, which Sanjay can actually comment on it, the satellites will get more and more complex, even though the size is getting smaller and smaller. The more the data, it's kind of getting better. For example, a standard imagery of with RGB as an image would be X, MB. But when you add extra layers into, let's say, a hyperspectral or a synthetic aperture radar, that particular file size goes 10x, because there is more information is in that particular, let's say, image. So from a few years ago, which used to take, let's say, about 3 days to a week to kind of make sense of one scene, is coming down to seconds. In the next 2 years, it will become millisecond.
So is there a possibility of doing this processing of the data, which at the satellite, so that you clean up and then you send a smaller packet, which could potentially decrease the latency? Is that a possibility, or is it already happening?
Sure, there's already some development happening in it. Sanjay, you are the better person because you're the orbital expert. And the overseas companies, the new space companies developing, is primarily covers that. Please, Sanjay.
Yeah, Sanjay.
Yeah, so I think, definitely what small satellites are paving way are for applications such as this. So, there's a lot of improvement that's happening in terms of, your electronics at the ground level, right? The number of transistors, density increasing, the typical Moore's law, so on and so forth. So in terms of onboard processing of data and just, sending the useful data down, the work has already started. There are few companies around the world who have already started to do these things, and it is only going to get better year on year. And same is also the case with a lot of sensors, right? I can give a comparison to the mobile phone industry, right? Like if you look
I
at
was just about getting that. I was trying to keep this in my phone. Yeah, in my hand. Yeah.
Yeah, so from a 0.3 megapixel to a 200 megapixel cameras, and making it almost like what do you call, distributing them in millions of devices has taken not a very long time, and same is also going to happen in the space industry. For the following reason, going back to where we started off with those large satellites things. So typically, most of these satellites used to use components which are radiation hardened, which have reliability for like 10 years, 15 years or beyond. Today, the most modern satellites are using commercially off-the-shelf components, so that your turnaround time to build these satellites is also reduced, and you can experiment with newer sorts of payloads for newer sorts of applications. Just to give you a perspective, we are in the process of launching 2 satellites. So if you see, this is the size of the satellite today, and
it is getting closer in size to my smartphone here. Yeah.
Yes. So, and we're looking at, the possibilities of picking up sensor data from ground, trying to create like decentralized networks for people to do secure communications, or look at, picking up signals and deriving intelligence out of those signals, so on and so forth.
So we will see smart satellites, not that they aren't smart already.
Absolutely. Absolutely.
So let me extend that. Right? So will we ever see personal satellites, like me having my own little satellite in space, with the space at which you're going?
Thank you. You asked this question. I think I'll tell you a nice incident that I had when I was interacting with a customer, right? So I showed the satellite and told him that it would cost you roughly the same cost as a very good model of a BMW car, right? The difference is that you can drive it on ground at maybe 250 kilometers an hour, but you can name this as your own satellite, and it's going to move 7 kilometers per second in orbit. So yeah, I mean, jokes apart, there are definitely we are looking at more and more people looking at utilizing these space assets. If not individual at an individual level, we definitely see that smaller organizations, 5-member companies, 10-member companies might actually look at having their own space asset and building their business around it.
Yeah, but I look forward to the day where my smartphone takes the escape velocity, right? But it's
sure.
So a quick thing, while we talked about, I wanted to touch upon one more use case, and this goes back to the earlier conversation about the latency in the data. So we all live in cities, and everyone has experienced traffic jams, and you always know that if you had known a particular road was going to be pretty busy, or something else is happening, you would want to take a turn, right? But these are, again, we are talking about at a city level, intra-city. So does a use case of trying to use the data coming from satellites, smaller satellites probably, do you think that do you think, and if so, by when do you think that it will start helping us with planning our daily journeys? Is that too far-fetched from where we are today? I'm talking about urban mobility, so it's a different use case. I thought I'll switch gears there.
Kris, maybe I'll take that question. So I definitely think that, the changes in the space industry are happening very, very fast. The kind of application that you're asking for might be, like 3 years away or, 2 years away.
Interesting. That's sooner than I thought you would say. I thought you would say 10 or 20.
No, so I think the road ahead for the space industry is pretty exciting. For example, I would say that there's a lot of thrust happening on connecting the unconnected, where Starlink, OneWeb, so on and so forth are bringing in a lot of changes. So one of the biggest challenges with these low Earth orbiting satellites to bring it to a consumer level is the price point. Right, the terminals on the ground that you use for communicating with these satellites are still the costs are still very high, and I believe that we're at least like 2 to 3 years away. When the terminal cost will drastically reduce, and that's when these sorts of applications would become feasible. But nevertheless, the types of applications that will evolve out of this industry are a great opportunity for entrepreneurs. I'll give you an example. See, for me and Kris are collaborating. Well, I mean, let's say you have a parcel of land somewhere in the country, right? You may not have to probably go there physically to see what is happening every day. Maybe we would, provide that as a solution to you. At a small for a small price, and these are things which are very much feasible. These are about entrepreneurs coming in together and making those applications feasible.
Interesting. So again, Kris, want to hear your thoughts also here. So there is a price point, Sanjay, that you pointed out, right? But price point is just a manufacturing constraint. There's also this increasing creativity on the type of use cases that could actually come in. Now, these two are converging at some point, and from what I see, you're quite optimistic about them converging pretty soon, that we could have a very consumer, like how you take phones, smartphones and phones, for example. You had the basic phone, then you had your handheld phones, then smartphones, and then that opened up an entire industry of app stores equivalent, right? And today we don't even think of the hardware as much. So you definitely see, and Kris, I want to hear, are you as optimistic as Sanjay on the timelines? I can see that it will happen somehow, but sure. What do you think are the timelines, and what if the timelines get delayed, what's stopping us?
Right. If you look at like general history of like the growth of electronics, primarily like everything, let's say in the case of phone or anything which is basically at once it's standalone kind of situation, right? The first was creation of the sensor. Then the second part was a sensor created to computing. The third phase, that's where we are in the space industry. The third one will be exactly like the moment of iPhone. It will be a sensor connected to a network. So I am extremely optimistic about that happening in a much shorter period. Once that happens, and I think many of us are already working towards connecting the sensor to the network, right, at a broad philosophical level, and it will happen in much sooner than you think.
Interesting. So we have about 5 minutes left. So I want to, so far we've talked about hardware, software, and quite a few interesting set of use cases. But more important to me than the use cases is the speed at which we think those use cases could actually come to fruition. But I want to talk about the third component of any sector, which is what we call as peopleware, right? So all of this requires a lot of smart individuals working in all the upstream, downstream, midstream, end user applications, analytics, and just creative individuals who can come up with creative use cases and lean on the infrastructure that a lot of other people are building. But in your experience of building Kawa and Dhruva, right? So how was your aspect of getting smart people on board? What type of people do you look for? Is getting the right kind of people a challenge, or is that happening smoothly? Kris, you start.
Right. So the classical way of looking at talent is definitely out. We may not have, let's say, 10 lakh people working in one company. Mm-hmm. My general approach, of course, if you're a young company, there will always be challenges, like, because you're inviting a very smart person to kind of join a journey, which may take like a patient approach towards things. And in the world where there are a lot of, if you are the only company out there doing one interesting thing, then it's fairly easy to kind of attract talent. Everybody will go there. It's like the 1950s IAS scenario. It's sexy, let's go there, right? Now we are competing not just with space companies. The competition is wider. There are so many amazing companies happening in India. It doesn't matter space or fintech or anything, right? The problems, like, it's kind of like at a mega distributor level. So companies like us, or like any other young company, whether you're operating in space or not, right? The skill sets are there. If you're truly committed, you can pick up a lot of skills, which is not a problem, right? And because of the Civil Air Space Agency existing and the defense establishments existing, there are a lot of coaching and mentorship can be provided by the former team members of these organizations. Mm-hmm. The challenge is that, like, there are so many interesting problems for the people to kind of solve. So we just need to kind of, like, fairly communicate what we are solving. And I think the second approach is that you don't have to join a certain company to kind of solve problems anymore. For example, if you're a product manager, or if you're an enthusiastic founder who's interested in using space to solve a larger problem, you can use our APIs and build a company yourself and become a more distributed approach. So my concept around talent is probably not exactly like, hey, am I getting employees? It's more that how many people I'm enabling so that they can go out and solve problems using space.
Very interesting. So you see it not just as a team issue, but it's as an ecosystem enablement issue, right? How quickly you can enable anyone else in the ecosystem.
Sure.
To do that. Great. Sanjay, what's your experience been and how do you see it?
Well, I mean, I think one of the main reasons why we are based in India and doing this in India is because of availability of very, very good talent and the value that we can create here for the global economy. Just to build on top of that, some statistics here, right? So there have been about 350 to 400 medium and small scale industries that have been supporting the Indian space program or ISRO over the last 30 to 40 years. So most of these companies already build like small components for the Indian space program, right? Put this in one bucket, right? You have more than 2 lakh engineers graduating every year from India, right? Put this in the other bucket. On the third bucket, you have a lot of former ISRO scientists who are willing to, channel their energy, support, initiatives of, going to space, future ambitions of space, right? Now, the fourth bucket, right? With what Kris mentioned, software is eating the world. And we are one of the leaders in that space, right? Now you combine all of these together, right? So I would say there is there is more supply than demand, I would say, but that would only converge as more and more space companies from India starting to evolve. And I think with Utkarsh's discussion with in space is a strong testament to that, right?
Yeah.
If you want to get to space, we have in space. So I think it's a good ecosystem that's evolving, and I think India will play a very, very important role in the space sector globally.
Awesome. So I think just to quickly summarize, we do see a kind of an inflection point not too far from now, where there will be the equivalent of a smartphone revolution in space tech sector itself, and looks like India is well poised to take that up, thanks to people like you, Kris and Sanjay, and many more who are watching. Hopefully, we'll have more next year. And I think one of the key insights was that when we talk about people, it's not just hiring a team, but it's enabling an ecosystem. I think that's a very powerful thought for us to have. We are out of time, but thank you so much, Sanjay. Thank you so much, Kris. This has been a wonderful session. Thank you for joining us and sharing your insights.
Thank you, Srikanth.
Thanks.
Thanks, Srikanth. It was really a great discussion, and we could see the miniature model or the actual satellite in that shape and size.